In this video, we are going to find the volume of pyramids with different types of bases. So first we need to look at the formula, general formula for the volume of a pyramid, and this is volume equals 1/3 times the area of the base. Remember, capital B means area of the base, times the height. Now I want to just briefly remember how this formula is different than the volume of a prism. The prism does not have this 1/3, okay? And that is because, and if we were in school right now, I could show you this. I can't right now. But if we have a prism that has the same base as a pyramid, so if we have a square, say a square prism, and a square triangular pyramid with the same base, okay? We should be able to fill that prism 3 times with a pyramid. Like, we could fill it with water or something and pour it in 3 times, it would be exactly the same. And that's why our actual pyramid is 1/3 of the size of a prism that has the same or similar dimensions, okay? But anyway, this is our general volume formula for pyramids. So let's find the volume of a square pyramid whose height is 3 squared root of 2 and the side of the base is 10. Now, when you do these, this is like the way that I would start out each of these, okay? This is a square pyramid. That means the base is a square, okay? This shape's going to look something like this. I'm going to see if I can kind of sketch it for us here. Oh, this is incredibly difficult because you can't actually see this stuff, but a square pyramid has a base that is a square, and then it has like nothing's curved. They're all these flat triangular planes that come and meet at a point. So this is like one side there, and this is another side. Okay, so it all kind of comes to a point at the top. Anyway, this is what I'm going to do, because we have a few terms we haven't talked about yet too, so bear with me as we go through. So this is the base of our prism. We have a side view of the prism and then a face. So the face is going to look something like this. That means that that's like one of these sides. Let me outline this in yellow. That's like this side right here. Okay? That is the face. So we have the base, the face, and we want a side view. Okay, so if we were to kind of spin this around, it would kind of look like this. Okay, so think about this here. This is pretty much what this is looking like. We want to, I'm going to grab a different color here, like cut it right down, and this is where our height comes in. We've got this like height directly from the center of our base, so it's coming up like right from the center, and we need to kind of draw this triangle that is made right here, and that triangle is going to look like this if we have a side view of it. So I hope you can kind of see where I'm coming in with this triangle, that orange triangle there, and how it fits inside our prism. Excuse me, our pyramid. Okay? So let's start labeling some things. So we have a few different terms we need to talk about before we can start actually labeling. We have something called the height and the slant height. This one is just height. It is not slant height, okay? Write this down. Height does not equal slant height. They're 2 separate things. And this is why. Okay? The height is the distance from the tip of the pyramid to the base. Okay, that's our height right there. Our slant height is that orange line that we just drew. That orange line we just drew, I'm going to turn it blue right there. That's our slant height right there. So the slant height is on the face of the pyramid, and the height is right in the center, like coming directly from the center. Okay, I hope that you understand that. If you do not, please contact me. Okay. So let's go and start labeling some. This is the height. So this is the one of the legs of our right triangle, our side view. So this is 3 squared of 2 right there. So that's this part. And the side of the base is 10. That means that the side of the base is 10. If this is a square pyramid, that means that both the sides of the bases are the same. Now we don't have anything to label on our face this time. That's okay. You might not always. And let's remember our formula for volume is 1/3 times the area of the base times the height. So the area of the base in this case is going to be 100 because to find the area of a square, take the side and square it, so that is going to be 100, and that is the area of our base. I'm going to write that as capital B. So our volume is 1/3 times 100 times the height of our pyramid. And if we're looking at this, see how our height is actually just written right here for us, and we drew it in on our side view. Okay, so we're just going to fill that right in here. This is times 3 squared of 2. Okay, 1/3 times 3 squared of 2 is 1, so we end up with 100 squared of 2 units cubed because this is volume, and that is how we find the volume in this situation. Looking at a slant height of 4 squared of 3, perimeter of the base is 16. So let's draw our pictures. We have our base, we have the face, and the side view. The side view is always a right triangle, okay? So a slant height is 4 square root of 3. That means that this is our slant height here. If we take a peek back at this last slide, it's that blue line that's coming across, okay? And it is also the hypotenuse of a right triangle. So that's 4 squared of 3. The perimeter of the base is 16. This is perimeter. How do we find the side of a square? Because this is a square pyramid again. If you said divide by 4, that is correct. So each of our sides are 4. So we need to find the area of the base, right? Volume equals 1/3 area of base times height. Area of the base, well, 4 times 4 is 16. Don't get confused. The perimeter and the base, perimeter and area are the same in this one case. And now we need to figure out what our height is. So this is where things get slightly more complicated. So just sit tight, follow along. If we are looking at our little right triangle that we have here, we need to find our height, right? That's our height. Okay. So if the perimeter of our base is 16, that means one side length is 4. Remember, this right triangle kind of sits right in here, kind of like the apothem, if you want to think that, of our square. And so that length right there is half of the side of our base. So this is actually going to be 2. And now we need to find h, and we know how to do this with the Pythagorean theorem. So let's go 2 squared plus h squared equals 4 squared of 3 quantity squared. And now I've been seeing some errors with this again, you guys. Make sure you square the 4 and the square root of 3. So this is going to be 16 times 3. So h squared, 16 times 3 is 48, minus 4 is 44. That means that h is the square root of 44, which is the same as 2 squared of 11. So our height is 2 squared of 11, and we can plug this all into our formula now. Volume, 1/3 times our base, area of the base is 16, times our height is 2 squared of 11. And be prepared to get some ugly answers on some of these, you guys. This one isn't very nice. We're going to put it all over 3. 16 times 2 is 32. Bring that square root of 11 in there. This is units cubed. Okay, there's our answer. Square pyramid with a slant height of 13 and height 12. So we've got a square pyramid. There's our base. There's the face. And here is the side view. Okay, this is something I did not do on the other ones, but I'm going to just fill in this slant height and the height right now. Okay, our slant height comes across right there. Okay, that is actually 13. If you were kind of curious about how those two pieces fit together. Okay, we need to find the third side of this. 12 squared plus, we're going to call that x. X squared equals 13 squared, 144. plus x squared equals 169. X squared equals 25, so x is 5. Okay, that was easy enough. So x is 5. And why did we need to find that? I guess I didn't tell you. Okay, this is why. We need to find the area of the base, and we have no information on that base piece right there. So we need to use this piece. Remember we said this is kind of like the apothem. If we go back here, remember I marked this in the apothem of the square. So this halfway across the square is 5, okay? That means the side of our square is 10. Finding the area of that base is simply squaring that 10, because this is a square. So the area of our base is 100. So when we actually find the volume now, we have volume equals 1/3 times the area of the base times the height, which is 12. Remember, this is our height right here. If you did not take notes on that, I suggest you go back and do that. 1/3 times 12 is 4. 4 times 100 is 400. And we will go units cubed, volume. There we go. Okay, let's talk about a regular triangular pyramid. This is not a square pyramid, you guys. So make sure you are paying attention to what problem you have. So in this case, a regular triangular pyramid, this is the shape of the base then. Okay, so our base is not a square on this one. Our base is a regular triangle. It has a height of 6, and the side of the base is 15 square root of 3. This is our base. Let's draw the face, if we want to look at that. And we can draw our side view here, okay? So we have a few things that we need to do. Our height is 6. We need to find now the area of our base. If we are given our height, which we are, which is very nice, we just need to find the area of our base. And how do we find the area of a regular triangle? Okay. We have a few options for this. Okay. The first, I guess we could go back and try to remember what we were given as far as finding the area of regular triangles before, and that was we kind of like cut our base in half, made a right triangle, and then did our half base height. We don't know what the height of this triangle is though, and that's where our problem lies. So we need to actually use our formula for a regular polygon, which was 1/2 times the apothem times the perimeter. So let me go back and get this part out of there, okay? We need to find an apothem then. That guy right there. We're going to draw our 30, 60, 90 triangle. We've got 30 degrees is that angle, okay? And then 15 divided by 2 is just 15 over 2. Let's grab a different color to keep this a little bit straight in here. So we have 15 over 2 square root of 3. And to find the apothem, we have to divide by the square root of 3. So this length, our apothem here, I'm going to write it out here just because I cannot really easily draw it in. That's this length right there, our apothem, okay? Our perimeter is 15 square root of 3 times 3, which ends up being 45 square root of 3. Okay, and that's how we're going to find our area of our base. So a few things I can actually fill in right here. This is 15 square root of 2, 15 over 2 square root of 3. You may certainly write that in there. And we need to recall our volume formula. 1/3 times the area of the base times the height. We're going to do this on all one step, you guys. So 1/3 times the area of the base is 1/2 times the apothem, which is 15 over 2, times the perimeter, 45 square root of 3. Okay, times the height, which is 6, coming over here. And let's simplify this. Okay, 1/3 times 1/2 is 1/6. 1/6 times 15 over 2 is 15 over 12. Times 45 square root of 3. Of course, you may be doing this faster or differently than me. Do not give me a decimal for your answer on this. Absolutely not, okay? We don't want to be messing with decimals if we are given a square root. Let's see. This cancels. 6 goes into 12 twice. So we end up with, let's see here. 675 is 15 times 45 Told you you're going to get some nasty answers. Keep the square to 3. Divide by 2. We can't simplify that anymore. Add our units cubed. And there we go. Let me know if you have questions.